physics is still a human possibility. Black holes are densely packed regions of space where the gravitational pull is so strong that nothing can escape it, not even light. Einstein predicted the presence of black holes through his general theory of relativity in the impactful life of Stephen Hawking. As a result, Hawking became one of the most revered physicists in the world, and one of the most admired by pop culture. Away from the limelight, however, Hawking, like Einstein, had an obsessive yearning to understand the universe, and never ceased to challenge our knowledge of it. One of his greatest contributions was the discovery of what is now known as Hawking radiation. In 1974, Hawking discovered one of the biggest breakthroughs of the 20th century, a groundbreaking interpretation of black holes, as well as an unprecedented interaction between the world of quantum and gravity. Hawking's discovery was so ingenious that it gave us hope that the theory of everything, the holy grail of physics, is still a human possibility. Black holes are densely packed regions of space where the gravitational pull is so strong that nothing can escape it, not even light. Einstein predicted the presence of black holes through his general theory of relativity in 1916, and we confirmed his predictions in 1974 when we observed our first black hole in the Milky Way. In the same year, Hawking discovered that black holes are like a vitamin tablet placed in water. They can dissipate in time and release energy. This is what we know as Hawking radiation today. But how can energy escape a black hole when nothing else can? Hawking used a quantum understanding to explain this. When we think of space, we imagine large, cold, empty places, but in reality, space is alive with the active creation and destruction of energy at the subatomic stage. Particles are created in pairs, matter and antimatter, and they are constantly created and destroyed in a concept known as annihilation. Hawking imagined a pair of particles created very close to the event horizon of a black hole. This is the boundary around a black hole from which nothing can escape. He then showed that these particles don't need to annihilate each other, since one of them can be sucked into the black hole. If the black hole is receiving negative energy, then it has to release energy in order for the law of conservation of energy to hold. Hawking also proved that black holes lose mass with time, and they don't last forever. But more importantly, he was able to arrive at this discovery by merging a quantum principle with the concept of gravity. This is by far the closest we've come to a theory of everything, a unified field theory, or quantum gravity. But, as with most things in science, the fact that we haven't found that one elegant equation does not mean that we have failed. In fact, maybe the real treasure was the discoveries we made along the way, many of which have paved the way for a brighter future for humankind. Most prominent ones. It suggests that subatomic particles such as electrons and quarks are made of tiny vibrating strings or filaments that twist and fold, creating everything in our universe. Just like the strings of a violin, they can vibrate in various patterns, creating different kinds of particles, including the gravity, a hypothetical particle that, according to quantum mechanics, should carry the force of gravity.
Hi there, sorry to pop up while you're...
On paper, string theory could unite gravity and quantum mechanics under one framework once and for all. The theory was popularized in the 60s and 70s, and its mathematics predicts small bundled up extra dimensions that give rise to a network of universes, or a multiverse. While this theory is prominent, it's highly untestable, even with access to the latest technology. String theory, though, is only the beginning. After almost 2 decades of tireless research, we've discovered the even with access to the latest technology. Even with access to the latest technology. Even with access to the latest technology. String theory, though, is only the beginning. After almost 2 decades of tireless research, we've discovered the Higgs boson. This proves that electrons and quarks inside the atom get their mass from an invisible field that spreads throughout space. The discovery took an effort from a group of 3,000 scientists that dedicated endless hours to the cause that would surely bring our species one step closer to understanding the universe. We've also discovered that all the atoms and light in the universe only make up less than 5% of the total content of the cosmos. The remaining 95% is composed of dark matter and dark energy, which are invisible, but whose effects dominate the evolution of our universe. Dark matter provides the gravitational pull that keeps galaxies together, while dark energy is responsible for the ever-accelerating expansion of our universe. While dark energy is responsible for the ever-accelerating expansion of our universe. For thousands of years, we've looked to the heavens and wondered what mysteries are hiding beyond the clouds. Since 1970, there have been more than 90 telescopes placed in orbit by NASA and the ESA to bring the universe closer to us. And with the James Webb Telescope that launched on December 25, 2021, we entered a new era of discovery. This telescope is the largest and most powerful one ever built, and its daunting task is to find the first galaxies that formed in the early universe, and peer through dusty clouds to see stars forming planetary systems. We may not have found the theory that unites quantum with gravity yet, but every discovery brings us one step closer to that ultimate goal of unification. Time on this planet. We've pushed the boundaries of existence by asking tough questions and working tirelessly to find the answers. Our species has been defined by its incessant thirst for knowledge and unwavering hope in a unified universe. 350 years have elapsed since our first big successful step in this journey, when Newton unified the heavens with the Earth, revealing that planets, stars, and apples are guided by the same set of laws. 200 years later, James Clerk Maxwell coupled electricity. 200 years later, James Clerk Maxwell coupled electricity with magnetism, space and time, and warped them into one fabric that we now know as space-time. Longer. Niggas acting all petty and such, mad cause I do my thing. If I pull out, then I'ma do my thing. Be honest, y'all niggas ain't ready for this. Is y'all ready? Do you want it? Yeah, I want it like that. Is y'all ready? Alright, y'all ready? Do you like it? Is y'all ready? That's right.